Hi everyone. In this lecture, I'm going to be going over factorial ANOVAs, which are also sometimes called two-way ANOVAs, which is to differentiate it from the ANOVAs we learned before, which are sometimes called one-way ANOVAs. So that's really all I'm going to be talking about in this lecture. To look at sort of the other stuff going on this week, be sure to check out just the plain old Lab 8 lecture that's also posted on Husky CT. So, factorial ANOVAs, let's kind of talk a little bit about what they are and the purpose of them. Some of you, I believe, do have hypotheses that factorial ANOVAs can address, and some of you may find these useful to do some exploratory analyses. Okay, so first of all, let's just refresh what we know about maybe what we can think of as regular ANOVAs or what's more formally called one-way ANOVAs. So one-way ANOVAs are used when we have more than two levels of an independent variable, and the independent variable is categorical, right? So we're grouping our independent variable in some way, and there's three or more groupings of that or levels of that variable. So the example that we've been using in class is, for example, let's think about if we're measuring level of anxiety when we expose participants to different forms of spiders. That could be pictures of spiders, videos of spiders, and real spiders. And we want to look at, again, their anxiety on a continuous scale. So just as a reminder, ANOVAs just examine the differences between three or more sort of conditions or levels within an independent variable. The outcome statistic is an F statistic. The thing about the F statistic is that it just tells you if there's a significant difference among your levels of your independent variables. It just tells you if there's a difference somewhere in there. You, of course, have to do post hoc tests, like a Bonferroni test, to see where exactly those differences are. The effect size that we use is the partial eta squared, but of course, we're still thinking that significant, quote unquote, in psychology terms, would be a p less than 0.05. That's still standard. And of course, if you need sort of another refresher of this, looking over your SPSS number 3 activity would be another great thing to look over for this. Okay, so what happens if we actually have two independent variables that we're interested in looking at the same time and looking at how they both influence a dependent variable or a single outcome? Well, that's when we can use factorial ANOVAs. So, for example, what if we're interested in spider exposure still, but we're also interested in gender? So in that case, we would have real spiders, pictures of spiders, and videos of spiders like we did before. But now we're also going to look at men and women. We'll just keep gender on a binary for now, just for the purpose of this example. So in this case, our independent variables are going to be what kind of spider exposure participants received and the gender of the participants. And I will say that when you're doing factorial ANOVAs, your independent variables, one of them has to be categorical. The other one can be continuous. So for example, it could be spider exposure and some sort of personality trait that we measure on a Likert scale. But just for this example, we're going to make it two categorical ones for simplicity's sake. Okay, so we're going to look at spiders and gender and how those things might work independently as well as interact in predicting anxiety. Okay, so now we get into what we call main effects. So a main effect is just the effect of one of your IVs, one of your independent variables, if you're completely ignoring or controlling for the other one. So in this case, we would have a main effect of this spider exposure, which is to say, what's the impact of the different kinds of spiders on anxiety, completely ignoring gender. So you can think of that as controlling for gender, or you can think of it as collapsing across the two genders. Essentially, this main effect we have here is exactly what we tested in the last one-way ANOVA, where we didn't really care about gender. We were just interested in how spider exposure affected anxiety. We can also test for the main effect of gender, which is to say, is there a difference between men and women in their levels of anxiety? What's the impact of gender on anxiety if you completely ignore what kind of spiders they were exposed to, right? We're sort of controlling for that, or you can think of it as collapsing across those conditions. And then finally, you have what's called an interaction. And this is where factorial ANOVAs get both more complicated, but also more interesting. So an interaction is saying, what if the impact of this spider exposure varies by or depends on gender? So we might predict, for example, that women are going to be scared of the videos of spiders more so than men, but men are going to be more scared of the real spiders compared to women. So I think of interactions as sort of the quote, it depends result. So if I ask you, are men or women more afraid of spiders? And you have these results, you might say, well, it depends. It depends on what type of spider they're being exposed to. And that right there is an interaction, because we can't clearly say, oh, women are more afraid or men are more afraid. That would be a main effect. We're saying that it depends or it varies by what type of spider that they're exposed to. So if we look at this graphically, we can essentially look at a main effect of gender here on the left. So let's say men are more anxious when they're shown spiders than women, just sort of doesn't matter what type of spider, it's just in this sort of test in general, men are sort of reporting more anxiety than women. On the right is the main effect of the exposure to the spiders. So real spiders tend to elicit the most anxiety, followed by videos of spiders, followed by pictures of spiders. And again, completely ignoring gender here, right? We're collapsing across the two genders. But we can also look at the interaction, which is essentially where we break it down into more fine-grained categories, where within each of the types of spiders, we're also mapping out how men and women each react to these. So we can see that according to this completely made up data, men have more anxiety reactions to real spiders compared to women. Women have much more anxious reactions to the videos of spiders compared to men, whereas for the pictures of spiders, there's not much of a difference, right? Like maybe women a little bit more than men, but that's probably not statistically significant. So that would be an interaction. Again, the amount of anxiety that someone has in response to spiders depends on their gender, as well as what type of spider exposure they're receiving. Okay, so if you have questions about that, definitely feel free to email me. Feel free to post sort of a question to the FAQ discussion forum on Husky CT so that I can respond not just to you, but also that everyone else can see the answer to the question, because probably a lot of people also have the same question. Just a reminder that I do have virtual office hours Wednesdays from 2 to 4 p.m. on Eastern time. Of course, if that doesn't work out for you, we can always schedule another time to meet. For the SPSS activity number 4, I posted this in the weekly overview, but just a reminder that this assignment is kind of mostly optional. If you're going to use a factorial ANOVA in your analyses, I do want you to do this as a practice first. If you are not planning on using a factorial factorial ANOVA as in your analyses, then you have the option of doing it. And if you end up doing it, I will drop your lowest SPSS activity score. So regardless, your total SPSS activity scores will be out of your best 3 exercises. Okay, everyone stay well, get lots of sleep, drink lots of non-alcoholic fluids, wash your hands, and I will talk to you all soon. Thanks so much.